So this lab is the torsional stress and angle of twist lab. We are going to use two specimens. They are both brass. Note their yellow color. One of them has a solid cross section. This is solid circle. And the other one has a tubular cross section. Note the hole in the middle. They both have the same diameter. I can measure the diameter with my calipers here. Okay, so that measures about 3.2 millimeters. And this is the tubular section, my solid section. Let's give that a shot. That's going to measure about 3.2 millimeters. Okay. Tubular section, I doubt I'm going to be able to get a wall thickness, but I can give it a shot. There's no way I'm getting a wall thickness. Come here. Okay. These are in, this side is intended to measure the inner diameter, but I mean, it doesn't fit, they're too small. So I'm just trying to kind of measure the best that I can here. And I get a wall thickness of about 0.9, 0.8. Oh, that went in just a little bit. And so we'll check out what the TechQuipment software says. All right. I'm going to start with the tubular cross section. It's going to go in here to our fixed end. Okay, so note there's no movement here, so this is my fixed end. And then I'm going to attach it over here to my loading end. I know this is the loading end. It's got the loading knob here that we've seen before in the bending stress and the column. Okay, so that's gonna load it, and we'll talk about the loading in a second. So these, I'm going to refer to these as chucks. So I need to tighten the chuck here, righty-tighty. Do that by hand before I get to my key. And tighten the chuck here. Okay. All right, so this is my right side, this is my fixed end, and you'll notice that my force output here is connected to this right end. Why? Because that's where the reactions are going to be for the fixed end, right? So it's going to be measuring the force on this fixed end. Okay. I'm making sure everything's aligned in the middle so that my tubular specimen here will not slip. Okay. Force output is connected here to the DFD. So my digital force display in channel 2. Okay. DFD is connected to the ADA. The ADA is also connected to the angle input. So we will not be actually measuring torque. We're going to be measuring the angle of twist and the force. Okay? And the torque will be, the angle of twist will be measured over here. That's what we'll be changing with our knob, is our angle of twist, and that's connected up here. Okay, so angle of twist at the free end, all right? Force at the fixed end. Okay. I'm also going to need a length for my angle of twist. The length that I want to measure is going to be from the connector tip to the connector tip of the chuck, because this is the free span that's going to be able to twist, right? It's being held in place here, so it's not twisting. So I need this free span. So using my metal ruler, and to the best of my ability, I get about 400 millimeter free span length from chuck to chuck tip. So that's going to be the length that I need to enter into my software. All right, we're doing torsional. I'm going to connect the ADA. It asks me to set the angle to 0. My angle is set to 0. There's a red line here that should be aligned with my black line angle of twist. I'm going to click OK. Now it wants me to set the angle to 25. So I'm going to twist counterclockwise. You can see my light red line here. until I get to 25. Okay, pardon me. All right, okay. Calibration was successful, thank you. All right, I'm going to take it back down to 0. All right. Angle 0. Load 0. Okay, and as per usual, I had it set to the wrong one. All right. Okay, we are going to be varying the force. We are using the tubular section first. And it seems to think that we'll be doing 3.2 diameter with a 0.8 wall thickness, which is about what we measured. And I'm going to tell it that we're using the brass. Okay, so everybody's 0. Oh, 500. Remember, we measured a length of 400. So let's scooch this over till we get to 400. Okay, everything's set. So I'm going to take my first readings at 0. 0 force, which means 0 torque, 0 angle. Everything's nice and 0, except the geometric properties. All right, I'm going to increase my angle to 5 degrees. Record the data. I'm going to increase my angle to 10 degrees. All right, about 10. Record the data. This is what we're changing here. Up to 15. And record the data. Up to 20. And record the data. Last one up to 25. And record the data. There we go. I apologize. I should have done that. All right. I have all the data for my tubular, so I'm going to unload and get it back to 0 angle of twist. And I'm going to switch out for my solid cross section. Okay, I have not moved any of the chucks, so my length should still be the same. -4. Now you've got me all worried about angles. Okay, come here, key. Tubular comes out, solid cross section goes in. Tighten. Make sure that it's all in the middle like it's supposed to be. I'm not pinching any edges. Okay, got a finger tighten. Now I'm going to key tighten. Don't have to crush my cross section. DFD is at 0. Angle of twist is at 0. So back to our software, I'm going to reset the angle to 0. Yes. Reset the load to 0. Yes. Close. I'm going to switch to the solid cross section. It is still brass. It is still 400 millimeters in length, and we are still varying the force. Okay. I have my table open from my tubular information. Okay. I said yes this time, and it's created a new table for me with a round section with all my fun information. Okay. 5-degree increments. Increase to 5 degrees. Hold on, I want to make it perfect. Here we go.
Much better.
Record. Increasing to 10 degrees. And record. Increase to 15 degrees. Ooh. Back off. And record. Increase to 20 degrees. And record. Increase to 25 degrees. Ooh, it's a lot stronger. And record. All right, there's all the information that we need for this lab.